Hello there, this is Hans Forschner with Napcon Engineering Network. This video goes over the conversion of equipment sound pressure level specification into a sound power level. What we hear is sound pressure, but it's caused by the sound power radiated by the source. In this video we talk about the conversion of sound pressure of a piece of equipment to sound power levels. And then also, if you have a large source, how do we define the noise emission of this large source, especially facades, roofs, or if you have a source like a machine object in an industrial building, how do you convert the pressure to a power, and how do we assign that power to the different surface areas of the machine? Let's get started. So here we have, we had an industrial building. So here we have a building. I use the construction tool to open up a box. I'll draw a box. It goes into construction tool, 5.5 by 14, and we rotate that so it goes right over that, and we click on the check mark and the program will generate the industrial building. All right, so this will be our generator. The generator is 4 meters in height. All right. I'll set it up a little bit above the ground. We go to the editor, and here we have four facades and the roof that are radiating the noise from the generator. Again, the default is 82 decibels at 3 feet. That is 0.9 meters. So at this point I will set up the highlight the facade and the roof. I'll define them and enable them as sources. The program will add an additional tab here, outdoor area source. We can assign a group information to that, and at this point open up the library, the source library. So here we have the generator LP, sound pressure level, 82 dB at 3 feet. And in terms of the values, they're defined from 63 to 8 kilohertz, A-weighted, so the lower row is A-weighted, the upper row is unweighted. And the definition in terms of the unit is LP level. This is important because to do the conversion, we have to right-click on the table and then select Convert Sound Pressure to Sound Power. If the unit is not LP level, this is not available. So you need to have it defined as sound pressure level, and then SoundPLAN will allow you to do the conversion. So we open up the conversion tool. There are 4 options. The first 2 are for point sources. The second are for basically box-shaped machines. We have full and half sphere, also a full sphere of a machine that is elevated, or a box that is directly on a reflective surface, half sphere. The general input is the distance, in this case 3 feet, 0.9 meters, the width 5.5 by 14 by 4. And when we have this input, we can see that the total surface area is 341.7. So that is the surface area 3 feet or 0.9 meters away from the piece of equipment. Total correction is 25.3 dB plus 82 will give us 107.3 dB sound power level. I'll click on the OK button. The program converts the spectrum, increases it by 25.3 dB. It converts the reference to sound power, and it adds a text right here underneath to show how it was converted. All right, so at this point I can save this, and I'll save that into this project, and I'll say this is the sound power level. On LP82. All right, so here we have our sound power level. And now at this point, how do we convert that and assign it to the different surface area? Here I'd like to open up a spreadsheet that looks very similar to the one that we just used to convert some pressure to some power. Now in this case I have a second table that shows me the different surfaces. I'll put in the general dimension. Alright, so here we have 22, two surfaces with 56, 77, and the total surface area is 233 square meters versus 341 square meters where it was 3 feet out from the cube. With this surface area we can assign the intensity level. So the intensity of each of the surfaces is 81.7. We can see the summation here, and the total is 105.3, which is again the sound power level. So this little table basically shows how we assign the different power levels to the different surfaces. And by using the intensity, we have SoundPLAN do the conversion based on the area of each surface and come up with 95.1 for the shorter sections, 99.1 for the longer sections, and 100.5 for the roof. And again, all those 5 will add up to 105.3. All right, so let's go back. Here we have the sound power level. I'll make a correction here. I copy that, and now I'll just call it LW prime. And this is sound intensity. And this is again for 5.5 by 14 by 4 meter dimension or size. All right. So we convert that, say it's sound intensity, and I correct it down by minus 25.3 decibels. Actually, it's 33.7. So let me correct it, minus 0.4, 81.7, and here 81.7. I click on the post edit and accept that, and now we have it assigned to these 4 facades. I'll give each of those a name: generator, facade, and generator roof. All right, so with this we have this generator assigned with intensity levels. One thing to note, we have to make sure, let me highlight them all, that it uses the reference that we have in the library. So make sure to have this check mark selected down here, so it uses the intensity element in the source library. All right, now for each of the source, again, we have the different surface areas, and so SoundPLAN will automatically convert that to each of those surfaces. The same thing applies if you have a machine inside the building. You do the conversion from pressure to power. You have the different surface areas. You know what the intensity is for the different surfaces. And then again, I would define a special element in the library that has the intensity level per square meter, and then assign it to the source. So let me do an example here. So here's a machine. I'll make it 1 by 1.5 or 2 meters. We'll have it 1.5 meter in height. I'll put it a little bit above the ground. And so here we have our source. And in this case, it would be the top surface and the 4 facades here, and again we define them as source and assign them to a machine sound intensity level. Same process as for the entire building, but in this case just for the machine. So again here in this case it would be let's say 80 decibels, and then here we have 1 meter by 2.5 by 1.5 meter, and then we do the conversion that way. Thank you for listening. If you have any questions, please leave a comment.